Good afternoon, everyone, and thank you for joining us for our webinar presentation of the new product, DSPbR Edge. Before I introduce our presenter, this is how today's session will run. We'll be recording this session and I'll send out a link of the recording post the event. If you have any questions during the session, please don't hesitate to post it in the Q&A in the top right-hand corner of the screen. We will endeavour to get to all your questions during the event. However, in the instance we're unable to answer them during the webinar, we'll follow up with you post-event. I'm Georgia Corey, Marketing Manager at RFI, and I'll be producing today's session. Mark Mazapika will be the moderator for the questions of today's session. And I'm going to place you in the very capable hands of our presenter, Alireza, Product Manager and RF Systems. He's the expert in all things DSPbR. Over to you, Alireza.
Hello and good afternoon, everyone. My name is Alireza Etemadfar. I'm the Product Manager for RF Systems at RFI Technology Solutions. First of all, I would like to thank you all for being here and for your interest in our newest product, DSPbR with TRex. I presume that most of you are already familiar with RFI and its business model. But just for the sake of people who are not much familiar with us, I would like to start the webinar with a very short and brief overview of RFI and what we do. Then we will have a look at our newest product, DSPbR Edge with TRex. And I will go through some of the example applications and their specifications. And after that, I will tell you about the newest feature that we have introduced in this new product, the game-changing technology. We call it the trunking extender or TRex for P25 networks. And I will tell you about the benefits. And I will wrap up with the deployment plan and the roadmap. As Georgia mentioned, if you have any questions during the course of webinar, please don't hesitate to post them in the Q&A section, and I will answer them when I get a chance. RF Industries, or RFI, was established more than 40 years ago in 1979, and over the years, we have become a major player in the industry. Today, we are the largest turnkey services provider in the IBC domain, and we are also the largest supplier of the rebroadcast infrastructure for the underground tunnels in Australia. We are a world-class manufacturer based in Sydney, Australia, and we have manufacturing facilities in Adelaide and Melbourne, but we provide our services and products globally. Apart from manufacturing and distribution, we also provide and offer professional services in project management, design, implementation, and installation. Okay, now let's have a look at our newest product, DSPbR Edge with TRex. I'm pretty sure that some of you are already familiar with its big brother, DSPbR. And what is DSPbR? It stands for DSP-based repeater. So it is actually a radio repeater that works based on digital signal processing. And Edge is the newest member of the same family. And why do we call it Edge? Because we believe it gives you the edge in indoor critical communications. In our Adelaide R&D facility, we have developed and designed a state-of-the-art product that we believe will resolve the complicated problem of indoor communications for public safety networks. And with our TRex feature for our P25 networks, we have also simplified the previously complicated and expensive implementation and design process. So we will see how this is done, but before we do that, I would like to give you a very quick and brief overview about the problem that we are trying to resolve. We all know that in Australia, in all the Australian states, the whole of GRNs or the government radio networks have outstanding outdoor coverage. But when it comes to the indoor coverage, the story is a bit different. And the main reason for that is that so far the implementation of indoor coverage for public safety networks or the GRNs has been really costly and complicated. And also the budget has been limited. So only a few of the top priority public indoor venues have been selected for these solutions. And in most of the scenarios, you either needed a dedicated in-building radio site or a solution like a shadow repeater, both of which have been expensive and complicated. But we believe with DSPbR Edge with TRex, we can now change that dramatically. We have a cost-efficient and easily implementable solution that can be implemented in almost all of the public venues and bring that critical coverage into those venues. Just to give you a bit of an idea how simple it is, you can think of any public venue where you don't have existing GRN coverage or the indoor coverage is compromised. You pick your venue, and based on the location of that venue, you pick a donor site from the host network. It can be any site from, for example, any of the GRN networks. And usually the donor site is the closest site to that venue. The configuration, the number of channels, and the frequency plan of that donor site determines the configuration of Edge. Each Edge chassis has the hardware and the inbuilt filter for 8 channels and also a single frequency band. And if you have more than 8 channels or more than a single frequency band, you can add more chassis. The Edge chassis itself is an IP-rated, outdoor, secure, lockable, and compact enclosure. It can be easily mounted on the wall or on the pole, indoors or outdoors. And once you physically install it, the configuration of it is also very simple and straightforward. It can be easily configured via the graphical user interface, and the graphical user interface itself is very user-friendly. And once you configure it, you just need to connect the antennas and the power, and you're ready to go. Now, obviously, you need a donor antenna. In most of the scenarios, the donor antenna is a directional Yagi antenna pointing towards the donor site. And on the service side, you need a few DAS antennas to cover your critical hotspots. So you won't need expensive DAS systems, including the filtering or expensive filters. So this way, we have minimized the capital expenditure. When it comes to the ongoing cost or the OPEX, the only cost that you have to think about is actually the power bill, which is really irrelevant in this case because the power consumption is only 130 watts, and also the ongoing ACMA frequency licenses fees. And in majority of the cases, ACMA frequency licenses, because I mean these repeaters are implemented as supplementary base stations, the cost of those ACMA licenses would be minimal. But obviously ACMA has to know that a specific repeater exists and at that specific location. Okay, so I would like to tell you about a few applications, but before we do that, let's see if you have any questions.
Yes, Alireza.
There is a question regarding the maximum number of channels that the unit can have. Is there a limit to the number of channels? I think you mentioned 8 channels. Can we go beyond that, or can we gang more units together?
Okay, sorry. Yes. Well, as I mentioned, the maximum number of channels each chassis can support is 8 channels, but obviously you can have more than that. And with that, you need to add more chassis. So for instance, if you have 16 channels or 24 channels, you can have 2 or 3 8 chassis. And we know that many of the GRN sites have more than 8 channels, so that's why we have enabled that feature in DSPbR Edge. Okay. Any more questions? Okay, so it looks like we don't have any more questions, so now we can move on to the next section. The first application I would like to cover here is the indoor coverage in the hospitals. We all know that having the GRN coverage or the public safety network coverage inside the hospitals is very important and critical. And the main reason for that is that we know that the public safety officers and the paramedics have to operate inside the hospitals regularly, 24 hours a day and 7 days a week. And whilst they're operating in the hospitals, they have to be able to communicate effectively to ensure their health and safety and also their operational efficiency. But we also know that the hospitals are usually large and complex buildings. They are quite cluttered and they're multi-story. So it's almost very hard for the outdoor RF signals to penetrate inside the hospital buildings. A few major hospitals may have existing radio networks for the indoor coverage, but due to the high cost of implementation of such solutions, many of the smaller to medium-sized hospitals don't have such a solution, and the coverage inside is patchy and unreliable. And we believe we can change that with DSPbR Edge with TRex. We can think of a medium-sized typical hospital, and you just put a Edge chassis on top of the roof, with a donor antenna pointing to the selected network donor site, and it can be any site in the donor network. Usually it's the closest site with good coverage, closest site to the hospital, which can give you good outdoor coverage in that area. And then on the service side, you have a few indoor antennas covering your hotspots inside the hospital. And the hotspots include the emergency room, the ambulance ramp, the car park, and so on. Any questions?
Yes, there are, Alireza. First question is it made in Australia?
Okay. All right, yes, it is made in Australia. It is developed and designed in Australia, and it is manufactured in Australia.
Okay. Second question, sorry. Second question is, does it support multi-carrier PA operation, MCPA?
Yes, so I'll get to that point later, but I mean, the amplifiers are multi-carrier. So, and each unit, as I said before, can support up to 8 carriers.
Okay, there's a few more questions, Ali. One regarding the channel capability and how it relates to the number of channels in the donor site. If, for example, a donor has 12 channels, can the edge, or can we configure the edge to repeat just 6 of those channels?
Yes, I mean, you can configure it in any ways that you like. So if you want to repeat only 6 channels, you just configure 6 channels. So it's quite flexible in that regard.
Okay, and what kind of planning considerations in RF terms do you need to consider when you're designing and implementing a DSPbR site?
Okay, so there are a few parameters that you need to consider. I mean, the path loss, the distance from the donor side, the amount of power you need to get that signal and amplify it, and also the amount of power that you want to repeat into your DAS system. So that's why in most of the scenarios, I'm going to get to that point later, but in most of the scenarios, we work with you to design the system properly. So there is a template that we can give to you, and you'll fill it out, and we get that information, and we have the system engineers here who can work based on that information and design the system properly for you.
Okay, there's a few more questions. I'm sure you'll get to this later, but what is the maximum per carrier channel power for an 8-channel configuration?
It is 30 dBm, but I'll get to that in later stuff when we talk about it.
And will we be providing an RF planning guide to assist designers?
Yes. So that's something that we are planning to prepare in future. At the moment, our system engineers would be happy to assist with any help that you need in terms of the design.
Questions are coming in thick and fast here.
Maybe we can answer the remaining questions at a later point.
Yeah, that there is a particular question which is probably relevant at this stage, and that is, does it support both FDMA and TDMA P25?
Yes, so it supports both phase 1 and phase 2. So in other words, it supports both TDMA and FDMA.
And also, has the product been endorsed or approved by the Telco Authority for use on the GRN, New South Wales GRN in particular?
So the tests and certifications are ongoing at the moment. Okay, thank you very much. So we can move to the next slide. So the next application I want to cover here is the shopping centers. We know that the shopping centers can get very crowded at times, and because of that, they are quite prone and susceptible to incidents and accidents. So again, it is very important for the public safety officers to be able to communicate safely and effectively in the shopping centers, especially when those accidents happen. And again, we know that similar to the hospitals, the shopping centers are complex and large buildings. A few major centers have been cooperating with the GRNs to implement a dedicated radio system inside them. But due to the high cost of such a system, in majority of those cases, the government radio networks have been bearing some of the cost. But the majority of the medium-sized to small centers don't have such a system, and the coverage inside is patchy. Again, we think we can change that with DSPbR Edge with TRex. Depending on the size of your center, you can use either a single chassis or a multiple chassis solution. In this case, we have a medium-sized shopping center, so we have 2 edge chassis on top of the roof, each of which is covering part of the center. You can think of the east wing and the west wing. And with that, we have also saved on the feeder length, and we have simplified the design and implementation process. The next application is the public service buildings. When we talk about the public service buildings, we're talking about places like the police stations, fire stations, and airport terminals. So you may naturally think that having a very good coverage, a GRN coverage inside places like police stations or fire stations is a given, but that's not the case in many of the cases, because many of those places, many of those stations have been built recently, and they have become more centralized, and there are large buildings, and they have been built according to the latest construction standards, and they are heavily shielded. So again, it's very hard for the RF outdoor signals to penetrate, and the coverage inside might be patchy. And we know that it's very important for the first responders to be accessible on their radios whilst they're at their bases. Otherwise, their ability to fastly respond may be jeopardized. And this can be changed with DSPbR Edge. In case of a police station, we can have a single chassis on top of the roof with the donor antenna pointing to the network donor side and a few indoor antennas covering your hotspots. The same idea can be applied to the fire stations as well. Public venues. The next example is about the public venues. So places like the cinema theaters, the concert halls, the exhibition centers, they can also become very crowded during the special events, and they are very prone to incidents. And again, it's very important for the public safety officers to be able to communicate whilst these incidents happen. A few public venues may have existing radio systems, but many of the smaller to medium-sized venues don't have that, and the coverage inside is not reliable. So this can again change with DSPbR Edge. Underground car parks. Well, we know that almost none of the underground car parks have good coverage inside them just because of the simple fact that they're located under the ground. So it's almost impossible for the outdoor signals to penetrate inside. And probably that doesn't need to change for many of those underground car parks, but at least with DSPbR Edge with TRex, now we have a cost-effective and workable solution for some of the more high-profile underground car parks, like the car parks of the embassies, the government buildings, the crowded public venues like the big shopping centers, the concert halls, and the exhibition centers. So these were just some applications, some example applications where you could use DSPbR Edge with TRex, but we should also keep in mind that the applications are not limited to these cases. You can think of any public venue where it doesn't have a good GRN coverage, and having that GRN coverage is desired, but so far the implementation of it has been impractical because of the high cost. So this can now be changed with DSPbR Edge. Okay, now I would like to talk about the product itself, but before we do that, let's see if you have more questions.
Not at this stage. There are some more questions, but I think it's probably best to address those later, Ali.
Okay, all right. Okay, in that case, we can continue. Let's have a look at the product itself. As I told you before, DSPbR Edge with TRex comes with in an IP-rated, compact, and outdoor cabinet, as you can see in this photo. And when I say outdoor, it is designed for outdoor environments, but obviously you can install it indoors as well. And once you open the hood, you can see the modular architecture inside. The modular architecture helps to simplify the maintenance and operation of the units in the field. I would just like to tell you a little bit about some of the more important high-level components, the internal components of DSPbR Edge. So the first component is the 2 duplexers. Each standard Edge chassis has 2 internal duplexers, which do the filtering and isolation at the donor side and the service side. In many cases, these duplexers can provide the required isolation, but for some of the more difficult scenarios where you have a more difficult bandwidth or frequency allocation, for instance, if you have too close TX-RX frequencies or a wider bandwidth, then you would probably need a more sophisticated customized filtering solution. And with that, we can offer an optional external filtering box to give you that customized filtering solution. The next internal module are the two TRex modules. And these are actually the heart of DSPbR Edge. These are the actual DSP and the power amplifiers. So they do the channelization and the amplification of the RF signals. And we have actually spent millions of dollars developing this state-of-the-art TRex module. So I'll tell you more about these two units in next slides. You obviously also need the power supply units or the PSUs to power up all the other active components inside DSPbR Edge. And there is a redundancy option with the PSU, so you can have two PSUs. Both of them are online at the same time, but if one of them fails, the other one takes over and your unit won't go down. And effectively, you will have a more reliable product. The interface panel is the interface to the outside world. It has an inbuilt cellular modem as well as an integrated Ethernet connection, through which you can access the unit locally or remotely for configuration and monitoring purposes. At the bottom of Edge chassis, you have all the connectors to the external equipment, including the service and donor antenna connectors, the power input, the Ethernet connection, and the alarm interface. Cooling in DSPbR Edge is convectional. It means that you don't need a fan. And you probably know that it is very important to have no fans for an outdoor electronic equipment because, first of all, it improves the reliability of your product, and also it keeps the product dust-free and clean. On this slide, you can see a very high-level schematic of the product, which gives you a better view of the modular and symmetrical design of DSPbR Edge. As I told you before, in each standard chassis, we have two duplexers. We have two TRex modules, including the DSPs and the power amplifiers. We have the two power supply units, the two PSUs with redundancy, and the interface panel, the interface to the outside world. And all of these units are connected to each other through the backplane. Okay, so let's have a look at the numbers. When we're talking about the specs of a digital radio repeater, probably the first question that comes to mind, and one of the audience asked this question before, is actually the maximum RF output power. With DSPbR Edge, with TRex, we can support up to 36 dBm composite. And obviously, if you have more than one carrier, your per carrier power will go down accordingly. So for 2 carriers, it's 33. For 4 carriers, it's 30. For 8 carriers, it will be 27. The maximum gain that we can deliver with DSPbR Edge is 100 dB. And it is a very high gain compared to any other product in the market. And the reason we can achieve that high gain is that we have a very sophisticated way of amplification. We have a 3-stage amplifier. The first stage of amplification happens in the digital domain. And after that, we have 2 stages of analog amplifiers. And with that, we can achieve 100 dB. The receive sensitivity is neg 116 dBm, but the recommended receive signal level from the donor side is neg 85 dBm. And the reason for that is that with 100 dB of gain, if you have neg 85 dBm at your input, your output will be 15 dBm per carrier, which is a very good typical level as the input into your DAS, because that means you can have up to 100 dB of loss in your DAS system and also in your air interface before the signal gets to your user, and that gives you a lot of flexibility in terms of your DAS design. The maximum noise figure is 6 dB. And as I said before, each Edge chassis has the hardware for 8 channels and a single frequency band. And if you have more than 8 channels or more than a single frequency band or a more complicated frequency allocation, you can have more chassis, and you can also have the optional external filtering box. I mentioned before that DSPbR Edge is the little brother of its big brother, DSPbR. So it is based on the same platform and the same engine. And DSPbR itself is a channelized repeater. We use digital signal processing to get to the bandwidth level of the channel itself. We only pass the channel. We don't pass anything else. We don't pass any other spectrum. And that is channelization. In Australia, we've been lucky because ACMA has been allowing the use of channelized repeaters only, but in other countries, that's not necessarily the case. In many other countries, they widely use broadband repeaters, which has caused a lot of problems, a lot of pollution, spectrum pollution, and also desensing of the donor site. But that's not the case in Australia. But apart from channelization, there are also a few other features that we have introduced with DSPbR Edge, which helps us to keep the spectrum clean and have very pure output out of the repeater. One of this is the design of the amplifier itself. As I mentioned before, we have spent millions of dollars developing those TRex modules, and we use a technique called DPD, or digital predistortion. And with that, we can have multiple carriers at the output, each of which has the spectral purity of a base station. The other important feature that we use is the equalization, and that is very important in the uplink because, as you probably know, in an indoor coverage scenario where you have multiple users talking to the same indoor antenna, those users might be located at different distances from the indoor antennas. And because of that, the signal level, the level of received signal by the repeater from those repeaters would be different as well. So if you just want to apply the same gain to all those signals and repeat them back to the donor side, the repeated signal back to the donor side will have different levels as well, which is probably not very good. So that's why we have equalization in the uplink, and by that we keep the consistency across the same channel group in the uplink. The other very important feature that we have in DSPbR Edge is the transmit gating, and that is also important in the uplink. Transmit gating means that we only transmit something back to the donor side if we have something to transmit. In other words, if none of the users in the indoor site are using their radio, so we don't have anything at the input of the repeater, we don't repeat and transmit anything back to the donor site either. And you can see a demonstration of this feature on the right-hand side diagrams on this slide. Here you can see the output spectrum of the repeater. And in both cases, we don't have any inputs. But on the top diagram, we have the gating active. So we don't have any inputs. And because we have the gating active, we don't have anything at the output either. Whereas in the bottom diagram, we still don't have anything at the input, but we have disabled the gating feature. And because we have disabled the gating, we are still transmitting something back to the donor side. And that is actually just noise. That is the white noise that comes into the repeater and gets amplified and sent back to the donor side, which is obviously very bad. Because imagine if you have multiple repeaters like that pointing back to the same donor side, your donor side will be easily desensed. But because we have introduced this feature in this product, we have eliminated that risk. If you have even 100 repeaters talking back to the same donor side, your donor side won't be desensed. Okay, now I would like to tell you about the game-changing technology that we have introduced, the TRex or trunking extender. But before we do that, let's see if we have any questions.
There is a question relevant to this section, Alireza. What is the actual maximum bandwidth that you can have in a single chassis?
Okay, so the amplifier itself, the TRex module, have a continuous bandwidth of 9 megahertz. Okay, so that is the bandwidth that the TRex module can accommodate. But then on top of that, we have the duplexer. So the standard duplexer has a bandwidth of 5 megahertz. If you use other duplexers, you can change that. So depending on a scenario, we can use different duplexers. We can have a narrower bandwidth duplexer or a wider bandwidth duplexer. But the hardware itself, the amplifier itself, has a continuous bandwidth of 9 megahertz.
And can that 9 megahertz be shifted within the duplexer bandwidth?
Yes, so if the duplexer bandwidth is wider than that 9 megahertz, then you can shift it. So, I mean, you can set the frequencies accordingly.
Thank you.
Any more questions?
Not at this stage.
Okay. Now we can talk about the TRex feature for P25 networks. So it stands for trunking extender. Just to give you a bit of background on the problem that we are solving with this feature, We know that traditionally most of the radio repeaters have been operating on the on-frequency rebroadcast and retransmission. And what that means is that they just repeat and retransmit the radio signals on the same frequency set that they receive them from the donor side. And obviously you can do that with DSPbR Edge as well. But if you do on-frequency transmission, there would be a few implementation limitations that you should be aware of. And the first limitation is the isolation between the donor and service antennas. If you are doing on-frequency transmission, usually you need a very high level of isolation between your service and donor antennas. And that is usually 10 dB higher than the gain of the repeater itself. So if you set the repeater gain to 100 dB, you will need 110 dB of isolation. The problem is that the implementation of that isolation is usually very complicated and very costly. It needs a lot of filtering and a lot of shielding. The second limitation is the so-called mush zones, and that happens in the border area. So in an indoor coverage scenario, you might have users at places like close to the entrance of the building, close to the windows, or outside the building in the perimeter around the building. And in those areas, it's quite likely that you receive both signals from the donor side, the original signal from the donor side, and the repeated signal from the repeater. And because they are on the same frequency, they can easily collide and get it and corrupt each other. So in those areas, you won't have a good quality signal, and your coverage will be compromised, and those mush zones will be created. So one way to get around this is to do frequency translation. And when you do frequency translation, you actually change the frequencies. You are retransmitting this radio signals onto a different frequency set compared to the original frequencies. And with that, you actually relax the isolation requirement, and also you are removing those mush zones. You can easily implement frequency translation in conventional networks, but the tricky part is that in trunking networks like the P25 phase 1 and phase 2, it would be very complicated to implement frequency translation. And the reason is that in trunking networks, the frequencies are not fixed. They're assigned by the network through the control channel. So that's what TRex is about. TRex is a feature that enables the frequency translation in P25 trunking networks, phase 1 and phase 2. And the way we do that is an innovative technique to manipulate and modify the content of the control channel. And with that, we have enabled frequency translation, and effectively, we have removed the mush zones and we have relaxed the isolation requirements. And because of that, we have improved the coverage and the quality of network. The graphical user interface, or the GUI of the Edge itself, as I mentioned before, is very user-friendly, and it looks very familiar. If you have worked with other RFI products in the past, it looks very familiar to you. The difference is that it has become more user-friendly and also crisper. The GUI itself is web-based. It can be accessed through any standard web browser, either locally or remotely through the Ethernet connection or through the inbuilt cellular modem. And the configuration of Edge itself is very easy, and it can be done in a few steps. You really just need to configure the frequency channels, the power levels, a few TRex parameters, and then you're ready to go. The GUI is also used for monitoring purposes, and you can monitor the status of the units and also the status of the alarms. There are some pre-configured internal alarms and some configurable external alarms in DSPbR Edge. And those can be configured through the GUI. And once they're configured, you can also monitor them through the GUI itself. But apart from the GUI, there are a couple of other ways to access the unit remotely and monitor the status of it. And one way is to use the inbuilt cellular modem to send SMS alerts to the designated phone number. So whenever an alarm is raised, it will automatically send an SMS alert to those phone numbers. DSPbR Edge also supports SNMP protocol, SNMP version 2 and version 3. So if you have an existing network management system that supports SNMP, you can easily integrate Edge with that system. Okay, just to give you a bit of summary on how DSPbR Edge has simplified the design and deployment plan, we saw that the TRex feature has actually relaxed the isolation requirements. And because of that, you won't need expensive filtering or multi-coupling. And because DSPbR Edge is a standalone repeater, it doesn't need a backhaul to the core network, and probably you wouldn't also need the core licenses. Edge is very flexible and scalable. It can be used in any indoor scenario, depending on the configuration of your donor site and the size of venue. You can have either a single or multiple chassis, and you can have the standard filters, the standard duplexers, or the optional external filtering backs. So we have a solution for every single scenario. The configuration is very easy and straightforward. It can be easily done through the graphical user interface, and you can also easily integrate Edge with your existing network management systems. Let's have a quick look at the roadmap as well. So what we have available today is the standard Edge in the UHF band in 3 different subbands from 400 to 470 megahertz. The input power is 110 to 240 volts AC. And as I said, there is an option for the redundant PSU. In terms of the feature, today we support P25 TRex, we support the SMS alerts with the cellular modem and the SNMP. In future, we are looking at developing other bands. The first priority is UHF2 from 470 to 520 megahertz, and we will also have a look at the VHF band. In future, we will also have a 48-volt DC version of Edge. And as I said, we are currently developing that external customized filtering box, which will be available pretty soon. But we are also looking at developing the RF over fiber linking and also the optional external battery backup. Okay, I would just like to have a quick word about its big brother, DSPbR itself. Well, obviously it is still available, and I'm pretty sure that some of you have already seen these units out there in the field because they have been widely deployed in many projects in Australia. Compared to its little brother, it has higher output power and higher gain, which makes it more suitable for outdoor coverage scenarios or very large indoor venues or the underground tunnels. The good news about DSPbR is that we now have TRex feature available with DSPbR as well. So if you're interested to implement the TRex feature on your existing DSPbR units, all you need to do is just to purchase an add-on card, which can be easily added to your existing DSPbR, and then you get the TRex feature activated. Okay, so that was the end of the slides. If you're interested to know more about this product or more about DSPbR Edge in particular, please don't hesitate to contact your local RFI sales representative. We are very interested in getting these units deployed out there in the field. And as I said, the test and verifications are in progress at the moment with the major network operators. If you're interested to get one of these units and test it in the lab or actually deploy it in an actual indoor venue, please don't hesitate to talk to us. We have a template, as I mentioned before, and our sales representative can help you to fill out that template. And a few pieces of information we need, and with that, our in-house system engineers would be able to work on a specific proposal for you. Okay, thank you very much for your interest. If there are more questions, I'm ready to answer them now.
Yes, there are, Alireza. Are we planning to develop a DMR version of the Edge? And if so, do we have plans to support Tier 3 trunked DMR?
Okay, so first of all, I should say that the existing DSPbR Edge can support DMR, so we have the filters enabled. The specific DMR filters enabled on DSPbR Edge. If it's the question of the bandwidth, I mentioned that, well, some of the DMR networks are within the existing supportable bands. But I mean, if you're talking about UHF2 band 470 or to 520, then that is something for future. It is on the roadmap. And in terms of the trunking, DMR Tier 3, if you're talking about a feature similar to TRex, that is again something for future. So we don't have it at the moment. But the DMR itself can be supported.
Okay. Also, can the Edge handle a change between a TDMA call and an FDMA call on a call-by-call basis on the same channel?
Well, that's something I need to check with our R&D team. I believe we can do that, but let's take your contact details and we'll get back to you with a definite answer later.
Okay. There's a question asking what is the group delay through the DSPbR Edge?
I don't know the exact group delay. Again, that's something I need to check with our design team, but it will be comparable to DSPbR itself. It's big brother, so it's not a huge group delay.
Just having a look through. I believe that covers it at this stage, Ali. Finally, there is a question regarding hot standby. Can we implement a hot standby configuration, which is, I guess, 2 edges, a 1+1 type configuration for cases requiring extremely high reliability?
The redundancy that we have is within the PSU. So as I said before, we have a redundant PSU. So if one of them fails, the other one can take over. But if you're talking about a full redundancy where you have 2 edges, no, we don't have that at the moment.
Okay. Are we able to do call traffic reporting with the Edge?
I'm not sure what you exactly mean by that question.
Okay, I guess it's, do we have any counters that look at the number of calls of a particular donor site going into a DAS system or vice versa, calls coming out of the DAS system?
Yes, yes. So there are some internal counters, and whenever one channel is activated, then we can count those. So.
Okay. All right, and I think that wraps it up for today.
Okay. Thank you very much, everyone. Thanks for your time and interest. I hope that you enjoyed the webinar. I now hand over back to Georgia.
Well, ladies and gentlemen, that concludes our webinar for today. Again, we'd love to thank you for your participation. We will send up a follow-up email, including a link to the recording of today's session to your registered email account. And of course, if you have any more questions that weren't asked directly, please don't hesitate to contact your RFI representative. Thank you, and we hope you enjoyed today's session.